up for the Great Egg Race.
Welcome to this rather unusual edition of the Great Egg Race. The problem we've chosen for this week is rather a tricky one, to test the inventiveness, ingenuity, skill, and perhaps sheer cunning of the teams. In fact, the problem is so demanding that we decided that you should have the opportunity to worry about it all night before starting work today.
Right, this way, gentlemen, please.
So, last night, still ignorant of their fate, the intrepid teams were ushered into the confines of a BBC cutting room to be shown a film.
Yeah. 3, take 1.
Good evening, gentlemen. The rather unconventional way of presenting the problem may have warned you that it's going to be an unusually tricky one. What I want you to do is to build a 35mm cine projector, a silent one, of course, not as complicated as this one here, which is capable of showing a 30-second film clip onto a 4-foot screen. To make it a bit easier, we've supplied you with a lamp house, an optical condenser, and a projection lens, so that you can concentrate on the design of the actual film transport mechanism, which you can either hand crank or drive electrically. Sleep well. A sleepless night has now passed, and our competitors have had a good chance to examine the materials and tools which we have provided. And they will have had a chance to decide on their policy. Now, gentlemen, before you tell us of your plans, please introduce yourselves.
Hello, we are a team from Cam Gears in Clevedon, and on my left I have Mr. Bernard North, who is a design engineer, and on my right Mr. Laurie Houston, who is a manufacturing manager. My name is Dennis German, and I'm also a design engineer.
Hello, we're a team from the Department of Biochemistry at Queen's University in Belfast. My name is Nigel Blumsom, and I'm a lecturer in the department. On my left is Carver Williams, who is also a lecturer in the department, and on my right is David Hull, who is a postgraduate student.
Hello. We're a team of process engineers from the Sheffield laboratories of the British Steel Corporation. My name's Peter Webb, on my right is Trevor Topham, and on my left Steve Baker.
And now I would like to introduce my veteran guest judge, much tried by egg races in the past, Ian Fells, Professor of Energy Conversion at Newcastle University.
Hello. Well now, gentlemen, you've had all night to think about this problem. Where do you think the really tricky parts are going to lie?
We think the transportation of the film and the lining up of the film with the sprockets is going to be the most difficult part.
And what about the lighting side of it?
Well, we're going to try a few experiments to see what the lighting side is before we decide whether that's a problem.
I see. All right. Now, gentlemen, before you were presented with this problem, did you actually know how a projector worked?
In a vague sort of way, yes.
A vague sort of way. Now,
it's even vaguer now, I think.
So the long night deliberating has only confused things?
To some extent.
Oh dear. Well, I hope that you managed to sharpen it up.
We'll sort it out.
Now, are you going to hand crank your projector, or are you going to drive it electrically?
Initially, we'll go for hand cranking, and if we've time, we'll perhaps see how we can fit an electric motor to the drive.
Yes, now I've always thought that a projector and a camera are, in a way, reversed. What about experience with cameras? Are any of you home filmmakers?
No.
No.
So you're starting from way back as far as that's concerned.
We are indeed.
Good luck with it.
Thank you.
Well, nevertheless, in about 5 hours' time, an expectant audience is going to sit in those seats to watch you screen your films. I suggest you project yourself into your problems.
Right.
chance. What have we here?
I don't know, one of the main things is to see whether that'll make onto the film. They're a small one of those. Where's that one that I had? The swine pig. Where is it now? The one I filed down. Oh, that's in there. Where's the other one that I filed? That's it.
Right, well, imagine that that's the baseboard, and this is our lamp housing, with the concave lens there, and there's the filament, and the condenser lens is here, and then the film will run down here, and we'll have the projector lens here, so that the picture will be projected onto the screen across here. So I think if we set up a baseboard which shows the layout of our parts so that we get a still picture, then we can try and do something about making the film move through the frame.
Movable.
Have this mounted so that we can adjust this backwards and forwards to get these distances just right.
Yeah.
What's all that for you? Got a white?
Let's get on there, bit in the middle.
19 mil, that is. 19 millimetres.
19 millimetres.
So let's write that down.
19 millimetres of that.
Bearing in mind the rather special nature of the problem, we've had to supplement the normal egg-race kit by a few extra goodies. They've got a projection lens, a lamp house complete with a condenser and a quartz iodine lamp, and this really rather magnificent construction kit which is full of gears and differentials and bevel gears and cams and so on. And of course we've also got a bit of electrical junk.
Yes, but of course that motor only turns at 2 revs a minute. It wouldn't really do, would it?
So it's a moment to step down gearbox, but
Yes,
they could use it backwards, couldn't they?
Oh yes, it might go hideously fast, I suppose. Yes.
Now, one of the problems they're really going to have to face is this question of intermittent motion. It's really what makes a difference between a slide projector and a cine projector. Well, I've got a model here which illustrates one of the ways in which this intermittent motion can be obtained. It's called a Maltese cross escapement. Let's just say in slow motion what actually happens. Every time the peg comes around, it moves the cross on a quarter of a revolution, and immediately having left the slot, it now locks the cross so that it can't move very much. If we were to link the film advance mechanism to the Maltese cross, we can see that it's advanced quite quickly, then stops for projection. If I now speed the whole thing up, we can see the Maltese cross moving in quarter revolution increments and being stationary in between. And that's the kind of thing which will have to be done. Now, Ian, I can see in front of you a rather yellowing, precious little bit of celluloid.
Yes, this is a piece of the first film ever distributed. It was made by the Lumiere brothers in 1895, and it's 35mm film. The very first film, 35mm, we still use it today. Now, here we have this rather marvellous projector built a little later, and again French, 1905, by Pathé. And we have the film with the holes in it, rather more actually in this case than the small number on this. As we turn the film, it moves through a series of sprockets. We have a little loop in the film here to give us a certain freedom of movement, and now we come to this escapement mechanism that you were describing. As the crank turns, the pin here moves into the Maltese cross escapement which you described, and it turns on the film one frame. As that frame goes past the lens, the light is blocked off by this blackened piece here. Yes. We don't want to see that particular movement, and then film is projected, the next frame, then it turns on one more frame, blackened out, and it does that 16 times a second. And the whole thing is remarkably robust in a, I would have said, a Victorian kind of way, and we could still use it today.
Well, I suppose in terms that a number of rather different mechanisms have to be linked together and rotate in synchronism, this really does present a pretty formidable problem for the team.
Can we just make a hole with it? Start, I think. Yeah, okay.
You seem to be nicely into the construction phase now. What exactly are we doing here?
Well, we had to make sure the lamp itself was aligned centrally with the reflecting mirror.
Oh yes,
so we had to make a little wooden stand for it.
And so that's okay now?
Almost, we think. It's a bit skew at the minute, but we need to, we can turn it around a little.
Now the stand, we have a wooden stand here with a hole in it. Now what's the, what does that do?
Well, in fact, the film is going to travel downwards through that hole onto some sort of take-up device.
I see.
There'll be a guide in here for the film.
You're making the guide at the moment?
Yes, that's right.
Can we see how it fits into this piece of... Well, first of all, what are you actually
Well,
doing?
this is the window that the film will actually be projected through into the condenser lens and so onto the screen.
So that's a 35
yes,
millimetre window, as it were.
Will be, yes.
And I'll make a couple of lines down here and fold it in, and then hopefully we can now inside there.
Oh, I see. That will
straight through. Yes. Probably not use all this, maybe only just.
So now then we'll have our light properly lined, and then our beam of light going through the through the film.
Right.
Yes.
So onto the screen.
I see you've got a handle to the problem as well.
Yes.
You've extracted this gearbox from one of the pieces of electrical junk we gave you.
Yes, right. Yes, the motor we were given basically gave us 2 RPM output from electrical input.
So it was a geared down motor which we gave you.
In effect, yes. We couldn't see any point in 2 RPM.
Yes.
So one of the things we required, in fact, was a motor, a unit that would gear us the opposite way. So we've dismantled the electrical and we're using it in the total reverse manner.
So you've made a handle here.
So we've made a handle.
The gears go on.
We shall.
Yes. The gears seem to be whipping on tremendously fast inside there.
Yes, so we've got a situation where we've worked out exactly what RPM we need on the output side.
Which is something what? Something more
it's
than
about 1,080 RPM to be precise. So we've yet to establish which gear we want to take off. But at some point we have to take off from this gearbox in order to drive through to give us the required speed for our mechanism that's to operate at 18 times a second.
So you've made yourself a claw, haven't you?
Yes, yes.
There's the claw. We've calculated the pitch of the sprocket.
Can just let me hold it, yes.
We've calculated the pitch of the sprocket holes in the film. We've measured them.
So this is 2 sprocket holes apart of it?
Yes, and the idea is that this will move in a motion something like this on a crank.
So each time it will push a film up or pull it down?
It'll pull it down by 4 sprocket holes, which is the pitch of each frame on the film. What we are trying to arrange at the moment is the crank mechanism that will actually drive this.
Well, he's cutting up one of our pie dishes.
Yes.
What's he going to make out of that?
Film can. This is going to be the disc. In order to project the film, you have to have light coming on and off, and we've decided that...
coming off so due to the movement of the film doesn't show.
That's right, yes.
That's right.
So we shine on for, we think, probably about 3/4 of a quarter of the 18 frames, and then during the movement we close off when we've got a gap here, or when the gap is filled here, we close the light off, move the film, light on again, project, light off, move the film, light on, project.
Well, the idea seemed to be there.
Yes, thank you.
A bit step forward kind of thing.
Yes, we get to...
And we'll try and get a chopper on there.
But what about that? Are we having this off and going underneath with it?
Yeah, if we get time.
And it seems to me that the red team are pretty close to having something which they can at least try.
Yes, let's see how that's likely to work, though.
Well, the intermittent gear they seem to be using is, if I can call it all very crudely, they've taken quite a large gear and left groups of teeth on it. I'm going to draw 4 groups. I think they've actually only got 3 in that now. And they've meshed with this another gear, a smaller gear, which has got teeth all the way around it, like that. And they're hoping that by turning the large gear, the small gear is going to be driven intermittently, so in steps of 4, in effect. It looks to me as if a test is actually coming up.
Oh.
Well, let's see whether anything is actually emerges from the end of the projector. Yes, picture. Well, it's really rather in slow motion.
Yes.
but
like about 3 frames a second.
There isn't at the moment they haven't got a shutter by the look of it, so we can see the movement of the frames.
Yes. But
is that actually moving?
yes, now the whole thing is actually moving anyway. If they can speed it up, though I suspect that it's going to be difficult meshing it.
5, 1.
Well, it looks promising. What they now have to do is to link a synchronized shutter in front of the lens.
Yes, I hope they realise that.
All we do is move that, pull it down and get it in like that.
Can I pull this back?
Like that, and it's in place then.
Get it on bottom dead centre.
The blue team has actually invented, as far as I can make out from first principles, an escapement mechanism which is very close to one which had been used in original film projectors. What we can see here is a lever which is effectively fitted like a crank onto a wheel, and its bottom end carries two teeth which are two perforations apart. And if you look at the path of that lever, it pushes the film, withdraws, pushes the film, withdraws, and so on, in a repetitive and discontinuous motion. Quite clever.
Oh, very clever. It'll have to be very precisely positioned, though. Otherwise, it's just going to half go into the teeth and tear the film.
But yes, but it's not only that. The actual stroke of it would have to be exactly 1 frame's worth. Otherwise, it would be gradually creep as the film progresses.
Well, yes, I expect we will get creep, in fact.
But I think it's very elegant.
Yes.
At this moment.
The yellow team are beginning to get their projector together now. They've got their light source and their lens. They can project the film onto a screen, and they have a device for moving it rather jerkily in front of the...
Looks like a hand at the moment.
Well, I think it's a hand drill that does it. But I think that they realise they need a shutter, and they're just putting the shutter together, and it's going to be very tricky to get it to spin at the right speed, and I think they've just realised that.
But they've, of course, also got to take a drive out at right angles, because their main motion is, of course, at right angles to the path of the light, while the shutter has to be parallel with the light.
Yes.
Shutter drive.
Yes, well, I think that they realise that. And the shutter drive, well, I'm not sure what they're going to use for a shutter drive. Perhaps a small electric motor. But then one can see the basic principles there of what looks like an ordinary slide projector, which has been made to move.
But I think it's now being mechanically driven by some agency underneath it.
Yes. Well, it's certainly jerky, all right, but whether it's actually jerking at 16 frames a second, we shall see.
They're using the handle to gear themselves up. I measured the ratio of the handle earlier on. It's about 3.5 to 1.
Definitely need the other two. Can we get a night?
As you can see, our audience has now arrived, and they're waiting patiently for the teams to put the finishing touches to their contrivances. In the meantime, we thought it would be amusing to show you some magic lanterns. These magic lanterns are rather remarkable Victorian inventions, which were able to show moving images long before the cinema was invented. The specimens which we have here are from a collection of Doug and Anita Lear, who regularly give magic lantern shows. Doug, what are you cradling so lovingly in your arms?
This is one of my favourites. It's called a Phantasmagoria lantern, and it was made by a man called Carpenter about 1850. And inside we have the original illuminant, which is what they call the Argand burner. That's colza oil and whale oil, right?
Yes.
Burning with a wick, add a little bit of camphor.
To make it whiter.
To make it whiter.
Yeah.
Then, of course, as the light shines through the condenser, the slide is inserted, and these are moving pictures. These are moving pictures before cinema, because each has an angle of movement, up and down, sideways.
Show us one of the slides.
Well, these are fascinating, and these are painted images with a sort of movement like this, you see, up and down, side, side, and also on the back, a slipper movement again.
So there are, in fact, many different sorts of pictures which you can create.
That's right, yes. You have lots of movement, and now, of course, moving to this one.
A rather magnificent triple-barreled contrivance.
A triunial, that's the name, a triunial lantern. They are superimposing now these images, one on top of the other, and that's, of course, the top lens and the middle and the bottom lens, all in register.
What sort of light source do you have inside these?
Well, this is a bit upmarket now. The date of this is 1885, and they're starting to use now the limelight system, oxyhydrogen limelight, and this is a little cylinder of lime with two gases being impinged on the lime, and that's where you get your light from.
And the trick, I suppose, is that have all three projectors focused on exactly the same point on the screen.
Yeah, this takes a while to register, of course, but that's what all the lovely brass knobs are for. They do it for you. It's a beautiful lantern, a Stuart Premier.
Now let's see what it can do.
Okay, right.
Go.
construction time is very nearly up. The yellow team behind me are putting the finishing touches to their machine, and the red team are already installing their projector, ready to test it. It's time for me to take my place in the audience.
May I show you to your seat, sir?
Thank you kindly. Thanks. I knew it would be difficult.
Before we start, let me introduce Richard McLaughlin, who's going to attempt to accompany the performances of the teams by appropriate piano music.
As you might imagine, we have a fiendishly complex system for marking and judging the teams. We're going to give them marks out of 100. And first of all, there's 20 marks for getting the thing in focus, and I must say they really ought to be able to earn those. Then we really don't want the film to flicker all over the place, so there are 30 points, or marks, for lack of flicker. These films are due to last for 30 seconds. If it runs properly for 30 seconds, there's another 30 marks. And then finally, 20 marks for engineering design and ingenuity, which all being well makes 100 marks in all.
Well, red team, are you in principle prepared to start projection? Well, I'll draw the curtain.
Lights.
And the house lights should come down now, please. Right, start your film, please. Tension is building. Looks as action is starting. Well, Ian, now for the marks. Now, you're the focus expert. It's the red team.
Yes, well, it really was in focus, and we could all read it. So I think 18 out of 20 for the focusing.
Now, as far as flicker was concerned, perhaps it wasn't quite so hot. And for flicker, we only awarded 13 out of 30.
And then time. It was supposed to run for 30 seconds, and it ran for something like 25 seconds, excluding breaks and stoppages. So we'll give them 25 for time.
So this means that the red team score a provisional mark that's apart from the judges' extra marks of 56. Now, yellow team, are you more or less ready?
Well, it's ready as well.
I'll draw the curtain. We have the house lights down. There's a small intermission whilst the drive is connected. Right. There we go. Undoubtedly moving pictures.
Maybe what happened if you stop the flicker? Eh? This is going slow. That's it. That's it.
I think that must be the end. Thank you. You must admit, there was a certain surrealist beauty about this last performance. Ian, let's just ask the audience, could you recognize who was on the film?
Yes.
Could you recognize what the person was doing? No. Well, Ian, let's get on with the marking. How about the focus mark?
Well, it was in focus, not quite as sharp as red, so we'll give them 17, I think, out of 20.
And for flicker, well, there was a certain detectable amount of flicker. So I think you scored 10 for the flicker marks.
Now, it actually took 4 times longer than it was supposed to take. It probably seemed like that to you, so I think 8 out of 30 for time, gentlemen.
So that makes the interim mark for the yellow team, that's the Queen's University Belfast, 35. Now, blue team, he opened the screen for you. House lights down. Do you feel you're going to make the end of the film?
That's it.
Well, let's have a crescendo from the piano to mark the. Right. Thank you very much. Would have been all right, only the handle fell off. Ian, for focus.
Yes, pretty good. 18 for focus.
And for flicker, well, the repetition rate wasn't very high, perhaps 5 for flicker.
Time a bit difficult to assess, actually. It's really fine. So 5 for time.
And this gives the blue team, that's Cam Gears, a provisional total of 28. Now, we've been joined by the other teams, and for the final crunch marks, which is your privilege to give. Let's start off with the red team, that is British Steel.
That's right. Engineering, design and ingenuity. Well, I must say I rather like the way in which it went round a right-angle bend. That was very good. And all in all, they also synchronised the way their shutter worked. So 17 for them, 17 out of 20.
Giving the red team a total of 73. Queen's University Belfast, that's the yellow team.
There was a strange machine. It was attractive in a simple sort of way, but they had inbuilt flicker. They had a design. It wasn't synchronised at all. So we'll give them 12 out of 20 for that.
Giving them a total of 47. And last but now no means least, blue, that's Cam Gears.
Oh yes, well it was a very ingenious device, and I'm sorry they didn't have an extra half an hour to really get it to tick properly. We liked the way this rather extraordinary sprocket tried to move the film, and it did some of the time, so we'll give them 14 out of 20.
Which gives them a total of 42. And this means that the red team, British Steel, are the winners of this episode of the Great Egg Race. Thank you, audience. Thank you, Ian, for being a nice judge. And come and watch again next week. Good night.
And in fact, next Tuesday's Great Egg Race gets cracking at the later time of 7:15.